Hello! In this video, we will be proving a quadrilateral is a parallelogram. There are 5 theorems for parallelograms. Theorems to prove a quadrilateral is a parallelogram. The first one, if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So we're going to mark both sides parallel. So let's mark this one and this one. These are opposite sides. And these are opposite sides. So if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. The second one says if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if you have a quadrilateral with both pairs of opposite sides congruent, then we have a parallelogram. The third theorem says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So we're going to mark the opposite angles congruent. And if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. On the fourth one, if the diagonals bisect each other, then the quadrilateral is a parallelogram. So let's draw in the diagonals. So that's when you connect non-adjacent vertices and the diagonals bisect each other, so they cut them into equal segments. If the diagonals bisect each other, then the quadrilateral is a parallelogram. And the fifth one says if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So if I have one pair of sides that are congruent and parallel, then I will have a parallelogram. Can we prove the following quadrilaterals are parallelograms? So here I have a pair of sides that are both 12. So they are congruent, okay, and they're parallel because of those arrows. So I know that this number 1 quadrilateral is a parallelogram, and it's because of the 5th rule that says if one pair of opposite sides is both parallel and congruent, then it's a parallelogram. Okay, let's look at the next one. I have a quadrilateral, and I notice that these opposite sides are congruent, and it's both pairs of opposite sides are congruent. So yes, this is a parallelogram, and this is because of our second rule that says if both pairs of opposite sides are congruent, then it's a parallelogram. On this number 3 quadrilateral, we have a pair of congruent sides and we have a pair of parallel sides. But I need to have either both pairs of opposite sides parallel or both pairs of opposite sides congruent. So, or one pair that is both parallel and congruent. So this one is not a parallelogram. And that's because I don't have, so I could have congruent sides and parallel sides, but it not be a parallelogram. For number 4, I have AC is 25 and BD is 25. So it says, basically it's saying that the diagonals are congruent, and that is not one of the rules for a parallelogram. Okay, let's look at number 5. We have opposite sides. Well, actually, we have all angles are congruent. So that means that the opposite angles are congruent. So this one is a parallelogram because of our third rule that says if both pairs of opposite angles are congruent, then it's a parallelogram. All right, now let's look at number 6. We have all the sides are labeled with side lengths. And I see that this side and this side, which are opposite sides, are congruent. They're both 10s. And then I have the 18 also congruent to the 18. So this one has both pairs of opposite sides congruent, and therefore it is a parallelogram because of our second rule. All right, let's look at number 7. So here I have some angles marked, but they're not the opposite angles. They're not the full opposite angles. But what I do have is 2 lines cut by a transversal, and the alternate interior angles are congruent, which makes these sides parallel. And here I also have a 42 and a 42, and these are alternate interior angles, basically 2 lines cut by a transversal. So that makes those opposite sides parallel. And this is the definition of a parallelogram, so yes, it's definitely a parallelogram, and that's our first rule. Okay, so now on number 8, I have the parts of the diagonals are marked with labels. So I have this side is 16 and this side is 16. So this diagonal is bisected because it divided it into 2 congruent segments. And the other one, the other diagonal, is also both marked with 7s. And so that diagonal is also bisected, which makes it a parallelogram. And that's our 4th rule. When the diagonals bisect each other, then it's a parallelogram. Now that we know how to prove a quadrilateral is a parallelogram, let's look at this. We have what values of x and y would enable you to prove the quadrilateral is a parallelogram. So for this one, I've got opposite sides labeled. So for both pairs of opposite sides to be congruent, I would need to set these two to be congruent. So I would have to say that 2x minus 2 is equal to 12 because they would have to be opposite sides congruent. So here I'm going to solve for x by making those sides equal. I'm going to add 2 to both sides and I get 14 equals 2x, and so x would equal 7 for this to be a parallelogram for those two. But then I also would need the y's to be congruent. So I have 2y equals 8. And so y would have to be a 4 so that I could have a parallelogram. All right, let's look at the next one. I have 3 labels here in angles, and I need to make sure that I have a parallelogram. Okay, so for this to be a parallelogram, I would need for my opposite angles to be congruent. So let's solve for the x first. So I'm going to put that 11x equals the opposite angle, 55. So if I divide by 11, I get 5. And so x would have to be 5 for this to be a parallelogram, but I still need for these 2 angles to be congruent. And I can't just put 5y because 5y equals 5y is not a legit, equation. So I do know that if it's a 4-sided figure, that the sum of all of those angles has to be 360 degrees. So we'll add together these two 55-degree angles and we get 110. And so we'll subtract 110 from 360, and we get 250 degrees left. So the other two angles will have to add up to 250. So if I divide that by 2, I get 125. So each of these angles have to be 125 degrees. So now we can set our 5y equal to 125. So when I divide by 5, I get 25. So if y is 25 and x is 5, then this is a parallelogram. All right, let's look at our last one. All right, so here I want to have opposite sides parallel. So it looks like I have one pair of opposite sides that I can make equal. And also, if I have alternate interior angles equal, then I have parallel sides. And so therefore, I would have one pair of opposite sides that's both parallel and congruent. Okay, we're going to start off by making our alternate interior angles congruent. So let's set 45 equal to 9x. So when I divide both sides by 9, x has to be 5 for this to be a parallelogram, for these two sides to be parallel. And now, if I want the one pair to be both parallel and congruent, we'll set 6y equal to 18. Divide by 6, and we get 3. So if x is 5 and y is 3, then we will have a parallelogram. All right, parallelograms on the coordinate plane. We're going to determine whether the quadrilateral ABCD is a parallelogram or not. So let's first plot our points. So A is at -2, 3. That's our A. B is at 3, 2. C is at 2, -1. And D is at -3, 0. There are multiple ways to show that this quadrilateral is a parallelogram, so let's try let's see if we can do this. Let's check to see if segment AD is equal to segment BC. And so we're going to find the length of AD first. So using the distance formula, we're going to take the square root of the difference between our x's, which is 1, and square that. And then we're going to add that to the difference between our y's, 3 and 0. So that's 3 squared. So I have 1 squared is 1 plus 9. So I know that AD is equal to the square root of 10. Now let's find the length of BC. Okay, so we're going to find the square root of the difference between our x's, which is 1, and square that, plus the distance between our y's, which is 3. And so I have, again, 1 plus 9, and I have the square root of 10. So I know that AD and BC are congruent. Now we can check to see if they're parallel. So let's look at our slopes, because if they are parallel, then they would have the same slope. Okay, so the slope we call M usually, of AD is up 3 over 1. And then the slope of our BC is up 3 over 1. And so since they have the same slope, we know that these two sides are also parallel. So I have one pair of sides that are both congruent and parallel. So ABCD is a parallelogram.